Imagine standing beneath a quiet night sky. The stars seem perfectly still. The moon hangs peacefully above the horizon. Nothing about the scene suggests that, somewhere out there, an abandoned piece of human machinery is quietly continuing a journey that no one originally planned. It has no crew, no destination programmed into its computers, no engines still burning, and yet it keeps traveling. Its mission ended years ago, but its voyage did not. There is something strangely beautiful about that thought. When we imagine space exploration, we usually picture dramatic moments. The countdown, the roar of engines, the brilliant plume of fire, lifting a rocket away from Earth. The astronauts waving before launch. The moment a spacecraft lands on another world. History remembers these moments because they are loud. They are exciting. They are easy to celebrate. What we rarely think about is what happens afterward. When the cameras stop recording. When the celebrations are over. When the spacecraft has done exactly what it was designed to do. Does the journey simply end? Or does another story quietly begin? Every rocket launched from Earth carries more than astronauts or scientific instruments. It carries pieces of itself. Massive fuel tanks, powerful engines, protective fairings, upper stages responsible for giving spacecraft one final push into the darkness beyond our atmosphere. Each component has a purpose. Each performs its task with remarkable precision. Then, one by one, those tasks are completed. A booster separates, its fuel exhausted. Perhaps it falls back toward Earth. Perhaps it lands gently on a waiting platform far below. Another stage ignites. It continues the climb. Minutes later, its own job is finished. The payload, whether a satellite, a lunar probe, or an interplanetary spacecraft, continues onward alone. The rocket stage has nothing left to do. At least, nothing that humans intended. Some stages return to Earth. They plunge through the atmosphere. Most burn into glowing streaks across the sky. Others survive long enough to splash harmlessly into the ocean. In recent years, some have even learned to land upright, gracefully, almost as though gravity itself had briefly agreed to cooperate. But not every rocket has that opportunity. Some are traveling far too fast. Some are already escaping Earth's gravitational embrace. Others are sent toward the moon, or even farther. Bringing them home would require more fuel than they have left. And so, they are left behind. Not because anyone forgot them, but because their work was complete. Imagine finishing a long voyage across the sea, only to discover that the ship itself continues drifting long after every passenger has safely reached shore. That is, in many ways, what happens to certain rocket stages. Their mission ends. Their journey does not. For years, they continue moving silently through space. No commands arrive from Earth. No engineers adjust their course. No one is sitting inside watching the stars pass by. They simply obey the oldest law in the universe: gravity. It is easy to imagine space as empty, a vast black ocean where objects either stop moving or wander aimlessly forever. Reality is far more elegant. Nothing in space truly stands still. Every planet, every moon, every asteroid, Every spacecraft, every forgotten fragment of metal is constantly falling, not downward, but around something else. The Earth falls around the Sun. The Moon falls around the Earth. The planets fall around our star. Even entire galaxies fall through the invisible architecture of gravity. Movement never really ends. It simply changes. Sometimes, a rocket stage that once served humanity becomes just another traveler, following these ancient pathways. Its engines remain silent forever, yet gravity continues guiding it through the solar system with extraordinary patience. There is something almost poetic about this transformation. A machine built by engineers, calculated to fractions of a second, designed for one specific task, gradually becoming part of the same celestial dance, followed by planets and comets. Perhaps that is why one particular story captured the imagination of so many people. News began spreading that an abandoned rocket stage, one that had long since completed its mission, appeared to be heading toward the moon. At first glance, the story sounded almost absurd. How could anyone lose a rocket? Surely every spacecraft launched into space is carefully tracked forever. Surely nothing simply drifts away unnoticed. But space has a way of humbling our assumptions. The object had not disappeared. Astronomers still knew it was there. What had become uncertain was exactly where its long, complicated journey would eventually end. Its path had grown increasingly difficult to predict. Tiny gravitational influences accumulated over months, then years. The quiet pull of the Earth, the constant attraction of the Moon, the ever-present gravity of the Sun. Together, they slowly reshaped its orbit. No dramatic explosion, no sudden change of direction, only countless gentle nudges, so small that each one seemed almost meaningless. Yet, together, they gradually guided an abandoned rocket toward an entirely unexpected destination. The Moon. It is remarkable to think about. A machine built to deliver a payload, a tool whose useful life lasted only a few hours, continuing to travel for years, eventually crossing hundreds of thousands of kilometers without purpose, without guidance, without anyone aboard, almost as though it had become something entirely different. Not a rocket anymore, but a traveler. Perhaps this raises an even more interesting question. When does a machine stop being part of a mission and become part of history? After all, that lonely rocket stage is not the only human object wandering beyond Earth. Across the solar system, there are silent machines still moving through the darkness. Some orbit the Sun. Some rest forever upon distant worlds. Some continue sending faint whispers back to Earth. Others have long since fallen silent. Yet all of them remain exactly where humanity left them. Together, they form something our ancestors could never have imagined. The first scattered traces of an intelligent species beginning to leave permanent marks beyond its home planet. Perhaps that is the real story. Not that a rocket was heading toward the moon, but that, for the first time in history, humanity has begun creating objects whose journeys continue long after we have stopped watching. And to understand how such a thing is possible, we first need to understand the invisible roads that connect the Earth and the moon. Because space is not empty, it is filled with pathways, ancient, silent, and almost entirely invisible. Tonight, we are going to follow one of them. If you could watch the Earth and the moon from far away, you might imagine a simple relationship. A planet, a moon, one quietly circling the other. It feels familiar, orderly, predictable, but appearances can be wonderfully deceptive. The space between the Earth and the moon is not an empty gap, nor is it a straight road waiting to be crossed. It is a place where invisible forces are constantly pulling in different directions. A region shaped by gravity so delicately that even the smallest change can slowly alter the course of an entire journey. When we think about traveling somewhere, we usually imagine choosing a direction. If you wish to visit another city, you simply drive toward it. If you wish to cross an ocean, you point a ship toward the horizon. Space does not work that way. A spacecraft cannot simply aim at the moon and fly in a straight line. Instead, it must follow the shape of gravity itself. Imagine placing a marble inside a large bowl. Wherever you release it, the marble follows the curve beneath it, not because it chooses the path, but because the bowl quietly guides every movement. Gravity does something very similar. Planets and moons create invisible landscapes through space. Every spacecraft launched from Earth moves across those landscapes, sometimes climbing uphill, sometimes falling downhill, always following the geometry created by gravity. This is why reaching the moon is far more difficult than it first appears. The moon is only about 384,000 kilometers away. On the scale of the solar system, that is surprisingly close. Yet every mission must arrive at precisely the right place, at precisely the right speed, at precisely the right moment. Too slow, and gravity pulls the spacecraft back toward Earth. Too fast, and it may overshoot the moon entirely. Approach from the wrong angle, and the spacecraft simply continues drifting into deep space. There is almost no room for carelessness. Every successful lunar mission is less like throwing a ball, and more like placing a leaf onto a moving stream, knowing exactly where the current will carry it. For this reason, engineers rarely send spacecraft directly toward the moon. Instead, they often use what is known as a transfer orbit. At first, the spacecraft remains bound to Earth. Its path stretches farther and farther outward with each carefully planned maneuver. Eventually, that orbit reaches the distance where the moon will be waiting, not where the moon is now, but where it will arrive days later. This is one of the beautiful paradoxes of orbital mechanics. Spacecraft do not chase destinations. They meet them. Everything depends upon timing. The Earth continues moving around the Sun. The moon continues moving around the Earth. The spacecraft follows its own carefully calculated path. 3 separate motions, perfectly coordinated. If even one is slightly misunderstood, the meeting never happens. Most of the time, the calculations are astonishingly accurate. Modern navigation is among humanity's greatest scientific achievements. A spacecraft launched from one small planet can arrive at a target hundreds of thousands or even billions of kilometers away with extraordinary precision. Yet, precision has limits. Eventually, the engines stop. The final maneuver is complete. The spacecraft reaches its destination, and then something interesting happens. The rocket stage that helped carry it there is no longer being guided. Its mission is over. But gravity is not finished with it. The stage continues exactly as physics demands. Sometimes, its path naturally carries it back toward Earth. Sometimes, it settles into an orbit around the Sun. Sometimes, it wanders through the complex gravitational relationship shared by Earth and the Moon. At first, its motion may seem predictable, but unlike an actively controlled spacecraft, no one is making corrections anymore. No engines fire. No navigation commands arrive. Every tiny gravitational influence begins accumulating. The Earth pulls, the Moon pulls, the Sun pulls. Even though the Sun is unimaginably distant compared to the Moon, its enormous mass ensures that its influence never truly disappears. Day after day, month after month, year after year, these gentle forces slowly reshape the object's path. There is another quiet influence as well. Sunlight. It may seem surprising, but light itself carries momentum. Every photon striking the surface of a spacecraft delivers an almost unimaginably tiny push. One push changes nothing. 1 trillion pushes still seem insignificant, but after years in space, even sunlight becomes part of the journey. Space rewards patience. Tiny forces become meaningful simply because they never stop acting. This is one of the reasons orbital mechanics can become so wonderfully complex. A spacecraft does not travel through empty stillness. It travels through an environment where invisible influences are always present. Some are powerful, some are almost impossible to notice. Together, they write every future trajectory. Imagine placing a small leaf into the middle of a gently flowing river. Nearby currents tug it one way. Hidden eddies pull another. A breeze nudges it from above. The leaf appears to wander almost randomly. Yet every movement follows perfectly understandable laws. The space between Earth and the Moon behaves in much the same way. Only the currents are gravitational, the winds are sunlight, and the river itself is the fabric of orbital motion. Perhaps this is why space often surprises us. We tend to think of gravity as something simple. Things fall downward. Planets orbit. The Moon circles the Earth. But when several large bodies influence the same object simultaneously, the story becomes far richer. A rocket stage abandoned after completing its mission is no longer following a carefully managed plan. It is simply responding to every force acting upon it. Sometimes, those forces guide it into stable orbits that last for years. Sometimes, they gently redirect it toward entirely unexpected destinations. The remarkable thing is that none of this happens suddenly. There is no dramatic turning point. No invisible hand reaches into space to change the course. Instead, the universe works through patience. One tiny adjustment, then another, then another, until years later, a completely different future has quietly emerged. It is almost impossible to appreciate these invisible roads By simply looking up at the night sky, the moon appears motionless. The stars seem fixed. Everything feels calm. Yet, hidden beneath that peaceful appearance, countless pathways weave through space, highways ridden by gravity, roads with no signs, no pavement, no beginning, and no end. Every spacecraft that leaves Earth enters this invisible network. Some complete their journeys exactly as planned. Others continue traveling long after anyone expected, not because they are lost, but because gravity never stops telling the story. And sometimes, those stories become far stranger than their creators ever imagined, because there are moments when an object no longer truly belongs to Earth, yet has not become part of the moon either. It exists somewhere in between, neither here nor there, a quiet traveler with no destination left to reach, almost as though it has become lost in the solar system itself. There is a word we often use without thinking very much about it: lost. A child can become lost in a crowded city. A ship can become lost at sea. A traveler can lose their way along an unfamiliar road. In each of these situations, the meaning is simple. Someone no longer knows where they are or how to return. But what does it mean for a rocket to become lost? After all, the rocket does not have a destination anymore. It does not carry a map. It has no pilot searching for the correct path. It feels strange to describe an object drifting through space as lost. And yet, that is often exactly how people speak about certain spacecraft and rocket stages, not because they have disappeared, but because their future has become uncertain. There is an important difference between orbiting and wandering. When a satellite circles Earth, its motion is predictable. Its path can be calculated years into the future. The same is true for the moon, for planets, for many asteroids. They all follow stable gravitational relationships. Their journeys repeat again and again. A rocket stage that has completed its mission may be different. Instead of remaining comfortably bound to one world, it may enter a region where several worlds compete for its attention. Earth still pulls. The moon also pulls. The sun never stops pulling. None of these forces suddenly becomes stronger than the others. Instead, they quietly compete. Every moment, every hour, every year. The rocket stage simply responds. Its path slowly changes. Not enough to notice in a single day. Sometimes, not even in a single month. But time is one of the greatest forces in the universe. Tiny influences, repeated endlessly, can transform almost any journey. This is why astronomers rarely say that an object has no orbit. Everything has an orbit. The question is simply, around what? Some abandoned rocket stages spend years circling the sun. Others repeatedly return near the Earth. Some briefly become captured by Earth's gravity before escaping once again. Others drift into surprisingly complicated paths that seem to change their character over time. To someone watching casually, The motion might appear almost random, but it is not random at all. It is simply complicated. Perhaps nowhere is this complexity more famous than in what mathematicians call the three-body problem. The name sounds technical. Its idea is surprisingly easy to appreciate. Imagine two dancers moving gracefully across a stage. If you know where each one begins, you can predict their motion fairly well. Now imagine inviting a third dancer to join them. Each movement influences the others. Each adjustment creates another. The choreography becomes dramatically more complicated. The Earth and the Moon already form an elegant gravitational dance. Add the Sun, and the choreography grows richer still. Introduce a small rocket stage into that performance, and predicting every future movement becomes astonishingly difficult. This does not mean the laws of physics stop working. Quite the opposite. They work perfectly. The challenge lies in the extraordinary sensitivity of the system. A tiny difference today may become an enormous difference years later. Imagine placing two leaves into a gently flowing river. At first, they float side by side. A few meters downstream, one catches a small current. The other misses it. Hours later, they may be separated by kilometers. Nothing dramatic happened. Only countless tiny differences accumulating over time. Space behaves in much the same way. A rocket stage may pass the Moon just a little closer than expected. The Moon's gravity changes its speed ever so slightly. Months later, that tiny change causes another close encounter to happen at a different angle, which creates another adjustment. Then another. Eventually, the object is following a path that no one would have predicted from a quick glance at its original trajectory. This sensitivity is one reason astronomers continue tracking forgotten spacecraft long after their missions have ended. They are not merely satisfying curiosity. They are studying motion itself. Every observation helps improve our understanding of these wonderfully complex gravitational systems. Powerful telescopes quietly photograph tiny moving points of light against fields of distant stars. Night after night, the object's position is measured, compared with previous observations, fed into increasingly sophisticated computer models. Most of the time, the predictions remain remarkably accurate. Sometimes, they require careful revision. The object has not changed its mind. It is simply following a path more intricate than anyone first imagined. This is exactly what happened with the rocket stage that eventually drew worldwide attention. Its journey continued for years, long enough for countless subtle gravitational influences to reshape its future. At times, its orbit seemed reasonably predictable. At others, small uncertainties began growing larger. Astronomers continued watching, refining their calculations, comparing observations made across different observatories. Not because the rocket itself remained important, its mission had ended long ago, but because its motion had become fascinating. It had become a natural experiment, a silent demonstration of how beautifully complicated orbital mechanics can be. There is something unexpectedly poetic about this. A machine built with extraordinary precision, eventually surrendering completely to the quiet patience of gravity. No engines, no software updates, no human decisions, only physics. One could almost imagine the rocket stage becoming less like a piece of technology and more like a tiny artificial asteroid, a human-made object joining the countless natural travelers already wandering through the solar system. Perhaps that is what makes these forgotten spacecraft so captivating. They occupy an unusual place in history. They are no longer active missions, yet they are not entirely relics either. They continue moving, continuing to interact with planets and moons, continuing to write new chapters without anyone aboard to witness them. Sometimes their stories continue for decades, sometimes for centuries, perhaps even longer. The universe is in no hurry. It allows abandoned objects to keep traveling long after their creators have turned their attention elsewhere. But eventually, even the longest wandering journey may encounter something waiting along its path. In this case, that something was the moon. A silent world that has preserved the history of impacts for billions of years. Natural impacts, ancient impacts, and now, one more made by something entirely different. Not an asteroid, not a comet, but a forgotten creation of humanity. A traveler whose mission had ended years before, yet whose final destination was still patiently waiting. For years, the abandoned rocket stage wandered quietly through space. It had no mission left to complete, no destination programmed into its guidance system, no one aboard waiting to arrive somewhere. And yet, without realizing it, it was slowly approaching one of the most familiar worlds in the night sky, the moon. To us, the moon often appears calm, unchanging, a permanent companion, rising and setting above the earth, just as it has for countless generations. Its face seems almost timeless, the same bright plains, the same dark Maria, the same craters that inspired stories long before humanity understood what they truly were. But the moon is not frozen in time. It is still part of a living solar system. Asteroids continue to strike its surface. Tiny meteoroids arrive every day. Occasionally, larger impacts reshape small regions of its ancient landscape. Unlike Earth, the moon possesses almost no atmosphere. There is no air to slow an incoming object, no weather to soften the scars afterward, no wind, no rain, no flowing rivers. A crater formed today may remain visible for millions or even billions of years. The moon remembers almost everything. That is one reason scientists became so interested when calculations suggested that the wandering rocket stage might eventually collide with it. At first, the prediction was treated cautiously. Orbital calculations are remarkably accurate. But when an object has spent years moving through such a complicated gravitational environment, small uncertainties always remain. Astronomers around the world continued observing. Night after night, new measurements refined the trajectory. Each observation narrowed the possibilities. Little by little, confidence grew. The object was no longer simply passing near the moon. It appeared to be heading directly toward it. There was something strangely surreal about the situation. This was not a spacecraft attempting to land. It was not carrying scientific instruments to explore the lunar surface. No astronauts were aboard. No final maneuver would slow its descent. It would arrive exactly as gravity intended. Silent, uncontrolled, traveling thousands of kilometers per hour. Naturally, some people wondered whether anything could be done. Could another spacecraft intercept it? Could engineers somehow restart its journey? Could humanity rescue one of its own forgotten creations? The reality was much less dramatic. Once the rocket stage had exhausted its fuel years earlier, its fate had largely been sealed. Sending a new mission simply to recover an abandoned piece of hardware would require enormous effort. Designing the spacecraft, building it, launching it, reaching the target, matching its complicated orbit, all of that for an object with no practical purpose remaining. It would have cost far more than the rocket stage itself had ever been worth. Sometimes, the universe quietly reminds us that not every journey can be undone. And so, scientists chose something different. Instead of trying to prevent the collision, they decided to learn from it. After all, impacts have always been one of the most important geological processes throughout the solar system. Every crater tells a story. Every collision teaches us something about energy, velocity, surface materials, and the history of planetary bodies. Natural impacts happen constantly across the moon. This one would simply have an unusual origin. For perhaps the first time, the incoming object would not be an ancient asteroid. It would be a fragment of humanity's own exploration. When the moment finally arrived, there was no dramatic fireball visible from Earth, no bright flash lighting the night sky. The impact occurred on the far side of the moon. The hemisphere permanently turned away from our planet. Hidden from direct view, the rocket stage struck the lunar surface at several thousand kilometers per hour. In the moon's vacuum, nothing burned. Nothing exploded in the way we normally imagine explosions. There was no atmosphere to create towering clouds of smoke. Instead, the tremendous kinetic energy released in an instant pulverized rock. Dust and fragments were blasted outward. A fresh crater was carved into terrain that had remained undisturbed for countless ages. For a brief moment, a machine built by human hands became part of lunar geology. That thought is surprisingly profound. For billions of years, the moon's surface was shaped almost entirely by natural events. Now, humanity had unintentionally added another chapter. Not through conquest, not through construction, but simply because one forgotten traveler continued its journey longer than anyone expected. Later, orbiting spacecraft photographed the impact site. The images revealed something unusual. Instead of a single, obvious crater, researchers identified a curious double crater. This surprised many scientists. One possible explanation involved the unusual shape of the rocket stage itself. Unlike a compact asteroid, a long rocket stage distributes its mass differently. Different sections may strike the surface in slightly different ways. The result became another scientific puzzle. Even an accidental collision had produced valuable information. It was a quiet reminder that nature often rewards careful observation. There is another fascinating contrast hidden within this story. Throughout history, scientists have deliberately crashed spacecraft into celestial bodies. The goal has often been to learn. The LCROSS mission intentionally impacted the Moon to search for water ice hidden within permanently shadowed craters. The DART mission deliberately collided with an asteroid to test planetary defense. Controlled impacts have become powerful scientific tools. This collision was different. It was never planned. No experiment had been designed around it. And yet, it still became an opportunity for discovery. Sometimes, science advances not only through careful planning, but through paying close attention when unexpected things happen. Perhaps that is one of the greatest strengths of curiosity. It refuses to waste even accidents. There is also something quietly humbling about imagining that lonely impact. No one stood nearby to witness it. No sound echoed across the lunar plains. No atmosphere carried the shockwave. Only dust rising briefly above the silent surface, before slowly settling once again. The Moon returned to stillness almost immediately, as though nothing unusual had happened at all. Yet somewhere upon its ancient face, another small mark now exists. One made not by an asteroid older than Earth, but by a creation of our own civilization. A forgotten rocket stage, a machine whose intended mission lasted only a matter of hours, but whose final journey continued for years. Its story could have ended there, with a quiet collision on an airless world. But in many ways, that impact is only a small part of a much larger story, because this rocket is far from the only human object that continues waiting silently beyond Earth. Across the Moon, across the solar system, humanity has already left behind far more than most of us ever realize. And each forgotten machine is still telling its own story. When the rocket stage finally met the Moon, its journey came to an end. Or perhaps, only one chapter ended, because, across the solar system, there are countless other machines whose stories are still unfolding. Some are moving, some are resting, some are still speaking to us across unimaginable distances. Others have fallen silent forever. Yet every one of them remains exactly where humanity left it. It is easy to imagine that every spacecraft eventually returns home. After all, that is how many journeys on Earth conclude. Ships return to harbor. Airplanes land at airports. Explorers come back with stories of distant places. Space exploration is different. More often than not, there is no return ticket. A spacecraft leaves Earth knowing that it will spend the rest of its existence far from the planet that created it. Sometimes, that separation begins only a few hours after launch. Sometimes, it lasts forever. The Moon itself holds many of these silent memories. If you could stand upon its dusty surface today, you would not find an untouched wilderness. Instead, scattered across the gray landscape are small reminders of humanity's earliest visits. The descent stages of the Apollo lunar modules still rest exactly where astronauts left them. Their ascent stages carried the crews safely back into lunar orbit, but the lower sections remained behind, patiently waiting beneath the harsh sunlight untouched by wind, untouched by rain, untouched by time in the way we experience it on Earth. Nearby, there are scientific instruments, reflectors that still bounce laser beams back toward Earth, experiments designed to study moonquakes, old television cameras, flags planted more than half a century ago. Although sunlight and radiation have almost certainly faded their colors beyond recognition, they still stand, not as symbols of ownership, but as quiet witnesses to one extraordinary moment in history. Even something as simple as a footprint has survived. On Earth, a footprint disappears within hours. Rain washes it away. Wind reshapes the ground. Plants grow. Life constantly erases yesterday. The moon does almost none of these things. An astronaut's boot pressed into lunar dust decades ago may remain visible for millions of years. Not because it is important, but because nothing is there to remove it. There is something deeply moving about that. A single human step, preserved longer than entire civilizations have existed. The moon is only the beginning. Far beyond its orbit, other machines continue traveling through the darkness. Some orbit the sun endlessly, long after the scientists who built them have retired, long after the newspapers stopped reporting their discoveries. Their work may be finished. Their motion is not. Consider the many spacecraft sent toward Mars. Some landed successfully. Others crashed. Some continue circling the red planet. Each remains part of humanity's expanding presence beyond Earth. Venus also keeps its own collection of visitors. The surface is so hostile that no spacecraft has survived there for long. Yet the remains of those brave machines still lie scattered across a landscape hot enough to melt lead. Mercury, Saturn, Jupiter, comets, asteroids. Every destination we have explored has quietly become home to at least a few artifacts of our curiosity. Then there are the pioneers that left the planets behind altogether. The Voyager spacecraft, the Pioneer probes, New Horizons, continuing toward the distant reaches beyond Pluto. These machines are no longer exploring worlds alone. They are exploring the space between worlds. Voyager 1 has already entered interstellar space. It carries no expectation of returning. Its tiny radio transmitter grows weaker each year. One day, its voice will fade completely. The spacecraft will continue traveling anyway. Long after the last signal reaches Earth, Voyager will still be moving among the stars. Silent, patient, almost unimaginably alone. Inside both Voyager spacecraft rests something extraordinary. A golden record, not intended for us, but for anyone or anything that might someday discover it. The record contains music, greetings spoken in dozens of languages, images of life on Earth, the sounds of rain, birdsong, a baby's cry, human laughter. It is less a message than a time capsule, a quiet introduction from one small civilization that hoped someone, somewhere, might one day be listening. Whether anyone ever finds it is almost beside the point. The act of sending it says something profound about who we are. We wanted to introduce ourselves to the universe. Perhaps that desire is one of humanity's defining qualities. to leave something behind, not out of vanity, but out of hope. As more missions leave Earth, the solar system slowly becomes something unexpected, not cluttered, not crowded, but inhabited by memories. Every spacecraft marks a moment when humanity reached a little farther than before. Every abandoned lander remembers a successful arrival. Every silent orbiter remembers years of discovery. Even failed missions tell stories. Some remind us how difficult exploration truly is. Others became the lessons that made future successes possible. In that sense, no mission is ever entirely lost. Success and failure both become part of a much larger journey. Historians often study ancient ruins on Earth, broken temples, forgotten roads, abandoned cities reclaimed by forests. These places reveal how earlier civilizations lived. Perhaps one day, future generations will study space in much the same way, not searching for alien ruins, but for our own. They may carefully preserve the Apollo landing sites, document the first rovers on Mars, protect the earliest spacecraft that reached distant asteroids. A new discipline has already begun to emerge. Some researchers call it space archaeology. It asks a fascinating question. How should humanity preserve the places where it first stepped beyond Earth? The answer is not simple. Unlike ancient monuments on our own planet, these artifacts exist on worlds shared by all humanity. Some scientists argue they should remain untouched forever. Others believe future exploration will naturally interact with them. Either way, these silent machines have become part of history. Not because they are technologically impressive by modern standards. Many are hopelessly outdated. Their computers are less powerful than the phones we carry in our pockets. Their materials have aged. Their batteries have long since died. What gives them value is not what they can still do. It is what they represent. They remind us of the first uncertain steps into an ocean far larger than our ancestors ever imagined. The abandoned rocket stage that wandered toward the moon belongs to this same family. It was never intended to become historic. It simply continued traveling long enough for us to notice. Sometimes, history is created on purpose. Sometimes, it happens quietly, without anyone realizing it, until years later. And as more missions leave Earth, a new question slowly begins to emerge. What responsibility do we have for the things we leave behind? Because exploring the solar system is not only about discovering new worlds, it is also about deciding how we should treat them. When most people hear the words space debris, they imagine something very specific. Thousands of broken satellites, fragments of old rockets, tiny pieces of metal racing around the Earth at incredible speeds. They imagine a crowded orbit where every collision creates even more debris. A place where humanity must carefully protect the pathways used by future spacecraft. That picture is real, but it is only part of a much larger story. Because not all human-made objects remain trapped around Earth. Some travel much farther, far beyond the crowded highways of low Earth orbit, far beyond the moon, far beyond any place where they might endanger other spacecraft. Out there, the meaning of space debris begins to change. An abandoned rocket stage drifting through deep space is not creating a chain reaction of collisions. It is not threatening astronauts aboard a space station. It is simply continuing its journey around the sun. There is an important difference between leaving something in Earth's orbit and leaving something in the solar system. Near Earth, space is becoming increasingly busy. Thousands of active satellites share the sky with countless inactive ones. Even a fragment, only a few centimeters across, can damage a spacecraft traveling at orbital speed. Engineers constantly monitor these objects. Sometimes, satellites perform careful avoidance maneuvers, simply to reduce the chance of a collision. It is a growing challenge, one that future generations will have to manage with great care. Deep space is another world entirely. The distances are almost impassable to imagine. A spacecraft may travel millions of kilometers without coming remotely close to another human object. The solar system is not crowded. It is astonishingly empty. A forgotten rocket stage may wander for centuries without passing near anything larger than a grain of dust. It is less like abandoning a car on a busy highway and more like leaving a bottle in the middle of an entire ocean. The bottle still exists, but the ocean is unimaginably vast. Even so, its presence raises important questions. Suppose humanity continues exploring the solar system for hundreds or even thousands of years. Future explorers may visit places we have never imagined. Asteroids, the icy moons of Jupiter and Saturn, D-dwarf planets, perhaps one day, even worlds orbiting other stars. As those journeys become more common, the number of human artifacts scattered across space will continue growing. Each new mission leaves something behind, sometimes intentionally, sometimes accidentally. Eventually, the solar system itself may begin to resemble a vast museum of exploration, not crowded, but quietly populated by traces of our earliest adventures. Imagine a spacecraft built 500 years from now. Its crew travels to an asteroid that humanity visited during the 21st century. There, resting exactly where it was left centuries earlier, they discover one of the first robotic landers. Its electronics no longer function. Its solar panels are covered with dust. Its cameras have long since fallen silent. Yet the spacecraft remains, not as useful technology, but as history. It would be difficult not to feel something standing beside such a machine. Just as archaeologists today experience a quiet reverence while walking through ancient ruins, future explorers may feel the same when encountering the earliest artifacts of the space age. This idea has inspired an entirely new conversation among scientists. Should some places beyond Earth become protected historical sites? The Apollo landing areas already occupy a unique position. They represent the first footsteps ever taken by human beings on another world. Many researchers believe they deserve the same respect we give to extraordinary historical locations on Earth. Future lunar missions may someday operate nearby, but perhaps they should avoid disturbing those original footprints, not because the dust itself is precious, but because it tells a story. The story of the moment humanity first stepped beyond its home planet. Similar questions may one day arise elsewhere. Should the first rover on Mars remain untouched, what about the first spacecraft to orbit another planet? Or the first probe to reach interstellar space? These are questions no previous civilization has ever needed to ask. Human history has entered entirely new territory. There is another responsibility that reaches even farther: protecting other worlds from ourselves. When scientists send spacecraft to planets or moons that might someday reveal signs of life, they take extraordinary precautions. Every spacecraft is carefully cleaned, sterilized, inspected, not because the machines themselves are fragile, but because the tiniest Earth bacteria might survive the journey. Imagine discovering life beneath the icy surface of Europa, only to realize that it was accidentally carried there by one of our own spacecraft. Such a mistake would forever change one of the greatest scientific discoveries in history. This is why planetary protection has become one of the most important principles in modern exploration. It reminds us that reaching another world is not enough. We must arrive responsibly. Curiosity carries obligations. The same curiosity that builds rockets must also learn restraint. Perhaps that is one of the quiet signs that humanity is growing up as a spacefaring civilization. Exploration is no longer simply about asking, "Can we go there?" Increasingly, we also ask, "How should we behave when we arrive?" That change may prove just as important as any technological breakthrough. For thousands of years, human beings explored continents, crossed oceans, climbed mountains, often leaving permanent marks behind. Now, our horizon has expanded beyond Earth itself. Every launch carries more than scientific instruments. It carries our values, our choices, our understanding of responsibility. An abandoned rocket stage drifting through the solar system may seem insignificant, just another piece of metal following the laws of gravity. But perhaps it is something more. Perhaps it is one of the earliest reminders that our actions now extend beyond a single planet. We are beginning to leave footprints, not only on worlds, but between them. That realization is both exciting and humbling. Because every civilization eventually becomes known not only for what it discovers, but also for how it treats the places it reaches. And perhaps that brings us to the deepest question of all. What does one forgotten rocket, silently traveling through space, ultimately reveal about the civilization that built it? For most of Earth's history, nothing made by human hands ever left the ground. Every tool, every monument, every work of art, every ship, every city, everything our ancestors created remained bound to a single planet. The sky was something to look at, not something to enter. For thousands of generations, the stars represented distance, mystery, wonder. No one imagined that one day objects built by human beings would travel among them. And yet, in little more than a century, that changed. The first airplanes carried us into the sky. The first rockets escaped the atmosphere. The first satellites circled the Earth. Then came the Moon, Mars, Venus, Jupiter, Saturn, comets, asteroids. Eventually, human-made machines reach the edge of the solar system itself. History rarely moves at a constant pace. Sometimes, entire centuries pass with only gradual change. Then, suddenly, everything accelerates. The age of space exploration has been one of those extraordinary moments. When viewed against the 4.5 billion years of Earth's history, it began only an instant ago. If the history of our planet were compressed into a single day, every rocket launch, every lunar landing, every spacecraft ever built would happen during the final fraction of the final second before midnight. We are astonishingly early. Perhaps that is easy to forget. The abandoned rocket that wandered toward the moon reminds us of something simple. Humanity has only just begun. When we hear stories about forgotten spacecraft, it is tempting to focus on the mistake, to think about lost trajectories, unplanned impacts, unexpected destinations. But perhaps we should see something else. Every abandoned rocket stage exists because something else succeeded. A satellite reached orbit. A probe continued toward another planet. A telescope began observing the universe. The discarded stage quietly fulfilled its purpose. Without it, the mission itself might never have happened. There is something quietly noble about that. It reminds us that exploration has always depended upon tools that continue no farther than the explorers themselves. Think of the great sailing ships that crossed unknown oceans. Many no longer exist. Their wood has long since disappeared. Yet without them, entire chapters of human history would never have been written. The same is true for rockets. Most people remember the spacecraft that reached their destinations. Few remember the stages that carried them there. And yet, those forgotten machines made the journey possible. Perhaps there is a lesson hidden in that. Not every contribution receives attention. Not every achievement becomes famous. Sometimes, the quietest parts of a mission are the ones that make everything else possible. The wandering rocket stage is almost a symbol of that idea. It completed its work, then disappeared into silence. Years later, the world briefly remembered it, not because it failed, but because its story continued longer than anyone expected. There is another reason this story feels meaningful. It reminds us how quickly humanity's relationship with the universe has changed. Our ancestors once believed the heavens were beyond reach. Now, pieces of our civilization quietly drift between planets. The solar system has begun collecting small fragments of human history, not because we intended to create a museum, but because exploration naturally leaves traces behind. Every footprint, every rover, every probe, every abandoned rocket stage, each one says the same thing. Someone was here. Someone was curious enough to come. Curiosity has always shaped our species. It carried people across continents, across oceans, across deserts. Now, it carries machines across millions of kilometers of empty space. That same curiosity built telescopes capable of seeing galaxies billions of light years away. It sent robots to worlds no human being has ever touched. It transformed impossible dreams into engineering problems, and engineering problems into history. Perhaps that is the most remarkable part of this entire story. The rocket itself was never extraordinary. It was not built to become famous. It was simply doing its job. Its unexpected journey became meaningful because of what it represents. Not a single machine, but an entire civilization learning how to step beyond its birthplace. Imagine someone living 1,000 years from now. Perhaps they travel routinely between planets. Perhaps journeys to Mars are as ordinary as crossing an ocean is today. To them, our rockets may appear primitive, heavy, inefficient, crude by comparison. Much as we look back today at the first wooden ships that ventured into unknown seas, yet those future explorers may also feel something else: gratitude. Because every great journey begins with uncertain first steps. The first airplanes flew only a few hundred meters. The first satellites completed only a few simple orbits. The first lunar missions carried enormous risks. The first interplanetary spacecraft traveled more slowly than later generations would consider practical. Progress always begins modestly. Looking backward, the earliest attempts often seem fragile. Looking forward, they become the foundation of everything that follows. Perhaps one day, children born far from Earth will learn about these early missions. They will study the Apollo landings, the Voyager spacecraft, the Mars rovers, the first asteroid missions, the forgotten rocket stage that eventually reached the moon. Not because these machines were perfect, but because they were brave enough to exist at the beginning. History has a gentle way of honoring beginnings, even imperfect ones, especially imperfect ones, because they remind us that achievement is rarely born fully formed. It grows slowly, patiently, one mission inspiring another, one discovery leading to the next, one forgotten rocket quietly becoming part of a story much larger than itself. Perhaps that is why space feels different from every frontier humanity has crossed before. The oceans eventually became familiar. Continents were mapped. Mountains were climbed. But the solar system still feels wonderfully unfinished. Every new mission adds another sentence to a story whose ending has not yet been written. And somewhere among those countless silent travelers, among the probes, the landers, the orbiters, and the abandoned rocket stages, the universe has already begun preserving the earliest chapters of humanity's greatest adventure. An adventure that, in many ways, has only just begun. But every story, no matter how extraordinary, eventually reaches a quiet ending, or perhaps not an ending, a beginning that continues long after the final page has been turned. Imagine looking up at the moon one last time. It appears exactly as it always has, calm, silent, ancient. Nothing about its familiar face reveals that scattered across its surface are small traces of a young civilization that once looked upward and decided to explore. There are footprints no wind will ever erase, machines that will never awaken again, scientific instruments that completed their work long ago. And somewhere among that quiet landscape, the remains of a rocket stage whose final destination was never part of the original plan. It is a strangely beautiful thought. When we build something, we often imagine its purpose, its beginning, its usefulness. We rarely imagine the life it may continue living after we are finished with it. A rocket is designed to launch, to separate, to deliver its payload. Everything about its engineering serves a mission measured in minutes or hours. Yet, sometimes, the universe extends that story far beyond anything its creators expected. The engines fall silent. The computers stop receiving commands. Mission Control turns its attention elsewhere. But gravity continues the journey, patiently, quietly, without asking anyone's permission. Perhaps that is one of the most remarkable qualities of the cosmos. It has no concept of endings, only transitions. An asteroid becomes a crater. A star becomes a white dwarf. A cloud of gas becomes new stars. Even abandoned machines become travelers. The universe is constantly transforming one story into another. The rocket stage that wandered toward the moon is a perfect example. From an engineering perspective, its useful life ended years before the impact. From the universe's perspective, its path was still unfolding. There is something almost comforting about that difference. We often measure success by immediate results. Did the mission work? Did the satellite reach orbit? Did the spacecraft arrive safely? These are important questions. But time has a way of revealing larger stories. The discarded stage eventually taught scientists more about orbital mechanics. Its unexpected collision became another opportunity for observation. Its strange journey invited millions of people to ask questions they might never have considered before. Sometimes, the value of an object is not found in what it was built to do, but in the curiosity it continues to inspire. That may be true of exploration itself. Human beings have always left traces behind. A stone tool, a painted cave wall, an ancient harbor, a lighthouse overlooking the sea. These remnants tell future generations something about those who came before them. Not merely what they built, but what they dreamed. The same is now becoming true beyond Earth. Future explorers may someday discover the earliest spacecraft of the space age. They may stand beside the Apollo landing sites, examine the first Mars rovers, visit silent probes resting on distant worlds. Perhaps they will even recover fragments of forgotten rocket stages, whose journeys continued long after history stopped paying attention. To them, these objects may appear primitive, their technology outdated, their materials weathered by radiation and time. Yet none of that will diminish their significance, because they represent something no future civilization can ever experience again. The beginning. The first uncertain steps away from a home world. Every civilization has moments like these, moments when possibility becomes reality, when imagination becomes engineering, when dreams become footprints. We happen to be living through one of them. That realization carries a quiet responsibility. The machines we launch today are no longer temporary visitors. Many of them will remain in the solar system for thousands, perhaps millions of years, long after every nation that built them has changed, long after every language spoken today has evolved, long after our names have been forgotten. Some of our earliest spacecraft will still be traveling, still orbiting the sun, still carrying silent evidence that, once upon a time, a curious species learned how to leave its planet. There is something wonderfully humbling about that. Not because our machines are eternal, nothing truly is, but because they allow a small part of our story to outlive us. Perhaps one day, far in the future, someone will encounter one of these forgotten travelers, maybe another human, maybe descendants living among the planets, maybe an intelligence we cannot yet imagine. Whoever they are, they will not simply find metal. They will find evidence of curiosity, evidence that one young civilization refused to remain beneath a single sky. The abandoned rocket stage heading toward the moon was never really the most important part of this story. It was simply the invitation, a quiet reminder that exploration does not end when a mission succeeds. Sometimes, the most unexpected journeys begin after the mission is over, when the engines stop, when the headlines disappear, when silence replaces celebration. The universe keeps moving, and everything within it continues moving too. Perhaps that is why space feels so different from every place we know on Earth. Nothing truly stays behind. Everything continues following invisible roads shaped by gravity and time. Every planet, every comet, every spacecraft, every forgotten rocket, each one remains part of a journey that never completely ends. Tonight, as you look toward the moon, it may seem peaceful, unchanging, timeless, but hidden within that stillness are countless stories. Stories written by asteroids, by ancient volcanoes, by billions of years of cosmic history, and now, by us. Not because we conquered the moon, not because we mastered the solar system, but because we became curious enough to reach beyond our own world. Perhaps that is the real legacy of the rocket that never came home. It reminds us that exploration is not measured only by destinations reached. It is measured by the courage to begin, by the willingness to accept that some journeys will continue long after we are no longer there to witness them. And maybe that is exactly how every great adventure is meant to unfold. A launch becomes a mission becomes a memory becomes history, and history quietly continues traveling through the universe. Long after the engines have fallen silent, long after the travelers have gone, long after the stars rise over another peaceful night on Earth.